three conditions of equilibrium: sigma h is equal to 0, sigma v is equal to 0 and sigma moment is equal to 0. And solving these three equations, we can find out our unknowns. So, that is how we are going to solve our numericals. To start with, I am taking first numerical of a simply supported beam. Suppose we have got a simply supported beam and it is subjected, it is having one end as a hinge support and second end as a roller support, right, and it is subjected to an inclined force of 10 kilonewtons at an inclination of 30 degree, okay, and it is also subjected to a uniformly distributed load of intensity 8 kilonewtons per meter. If you remember, uniformly distributed load is always given in terms of intensity kilonewtons per meter, because per unit length the load transferred is uniform or equal. That is why it is called as a uniformly distributed load. Suppose the distance between the point load and a support is 2 meters, this is 1 meter and this is 1.5 meters. Okay. First of all, we will name it as A, B, C and D. Now, to start with, as you remember, our first step is to draw a free body diagram. Now, to draw a free body diagram, first of all, we have to convert our load intensities in the form of a concentrated load. Now, to draw a free body diagram, so step number 1, step 1, that is draw free body diagram. Okay. Now, to draw a free body diagram, we have to take all the points at which the forces are acting in vertical downward direction. So, in vertical downward direction, we will take all the points at which the forces are acting with a light line. After that, we will draw again one horizontal line. After drawing the horizontal line, we start with our support D. Support D has a roller support. So, the roller support will be subjected to how many reactions? Only one reaction. In which direction? Vertical direction. Why vertical direction? Because it has got a free movement in the horizontal direction, and reaction is always produced where resistance is offered. So, for roller support, resistance is there in the vertical direction. So, we will show vertical reaction as it is vertical reaction V and as it is support D. So, V D. Then we come to C D. So, when I come to point C, what is the distance of point C? It is 1.5 meters, right. Now, it is 1.5 meter. I want to convert this in terms of a point load, because it is at present in terms of kilonewton per meter. I want the answer in terms of kilonewton. So, what I have to do? I have to convert it in terms of a point load. So, I have to remove the term that is meter. So, if I want to remove that particular term, how can I remove? By multiplying the intensity with the distance at which it is acting. So, what it will be? Equivalent will be 8 kilonewton per meter into 1.5 meter. So, meter will cancel out, 15 8s are, so 4 kilonewtons. So, that will be the point load acting on that particular beam. That is 12 kilonewton force will be acting on the beam. Now, where will it act? So, this 12 kilonewton force will act at the center. Which center? Center of the UDL span. So, for 1.5 the center will be 1.5 divided by 2 and that is 0.75. So, we will show over here at a distance of 0.75 and 0.75 we have got a point load of intensity 12 kilonewtons. Okay. So we have converted our UDL 8 kilonewton per meter in terms of intensity or a concentrated load of 12 kilonewtons, and concentrated load always acts at the center. So 1.5 center is 0.75 and 0.75. Then we come to the second point, that is our point B. The distance between point B and C, that is nothing but 1 meter. So we write it as 1 meter. Now at point B we have got an inclined force, right? So at point B we have got an inclined force, and the inclination with respect to horizontal is 30 degree. Inclination with respect to horizontal is 30 degree, right? Now because our support reactions are also vertical, I have to convert my inclined force into two components, equivalent components, one in the horizontal direction and second in the vertical direction. So we have to resolve that particular inclined force into two components. Now what is our thumb rule? The thumb rule is we have to see that our force is inclined with respect to which axis. The force is inclined with respect to horizontal axis, so my horizontal component will be cosine and my vertical component will be sine. It is a very simple logic that you all know, that if this is your x axis and if this is your y axis, if force is inclined at an angle of theta with respect to x axis, its vertical component and horizontal component will be as p cos theta and p sin theta, right? Now suppose if I say that the force is inclined at an angle of theta with respect to y axis, right? That means what will be the inclination of force P with respect to x axis? With respect to x axis, its inclination will be 90 minus theta, right? Now if I want to resolve my force into horizontal and vertical component, again my force is inclined at an angle of 90 minus theta with respect to horizontal axis. So we know what is cos of 90 minus theta. Cos of 90 minus theta is nothing but sin theta, so that will be equal to p sin theta, and this will be equal to what? P into sine of 90 minus theta, and that is equal to p cos theta. So what is the thumb rule? You have to see that if your force is inclined with respect to horizontal axis, your horizontal component will be cos. Similarly, if your force is inclined with respect to vertical axis, your vertical component will be cos. So in our numerical, the force is inclined with respect to horizontal axis, so our horizontal component will be cos and the vertical component will be sine. So we can show it over here that we will have two components, one in the horizontal direction and one in the vertical direction. So horizontal component will be 10 cos 30 and vertical component will be 10 sin 30. So 10 cos 30 and 10 sin 30 we can find out as 8.66. So 10 cos 30, that is equal to 8.66, and 10 sin 30, that will be equal to 5 kilonewtons. So this we have to show it over here. So at point B there will be one vertical force, and that vertical force value will be equal to 5 kilonewtons, and another force, that is horizontal component, will be acting, and that horizontal component intensity is equal to 8.66 kilonewtons. Then we move to our point A, and the distance between point A and point B, that is 2 meters. So 2 meters will show over here. This is our point A. Now we can say that our point A is a hinge support. So at hinge support, how many reactions will be there? There will be two reactions at hinge support. One will be in the horizontal direction, that is VA, and as it is vertical, so V, and A is the point at which it is there, so VA, and another will be horizontal reaction, that is HA. that is HA, right. Now what we have to do? So our first step is what? To draw a free body diagram. I have made the beam free from all the constraints. I have replaced it with all the vertical and horizontal forces acting, and at what angle these forces are acting, right. Now our second step is we have to apply the conditions of equilibrium. So our step number 2 will be to apply the conditions of equilibrium. What are the conditions of equilibrium? So conditions of equilibrium are sigma h is equal to 0, sigma v is equal to 0, and sigma moment is equal to 0, right. So to start with, first is sigma h is equal to 0. Now what is our sign convention? If the force is moving towards positive x-axis plus, if the force is moving towards negative x-axis, we will take it as minus. So to start with, first is HA. HA is moving towards negative x-axis, so it will be minus HA, and 8.66 is moving towards positive x-axis, so it will be taken as plus. So and that is equal to 0, so implies HA that is equal to 8.66 kilonewtons, right. Now we come to our second condition. What is our second condition? Second condition is sigma v is equal to 0. What is our sign convention? If force is moving in the upward direction, positive; if force is moving in the downward direction, negative. So for sigma v is equal to 0, we start with Vd. Vd is acting in vertical upward direction, it will be taken as plus. So plus Vd, then 12 kilonewton in the downward direction, minus, then 5 kilonewton again in the downward direction, minus, and Va in the upward direction, plus, that is equal to 0. So we get an equation Va plus Vd that is equal to 17 kilonewtons. This is our equation number 1. This is our equation number 1, right. Now what is left? Now the left is our third condition of equilibrium, and that third condition of equilibrium is sigma moment is equal to 0. And what is our sign convention? Clockwise moment is to be taken as positive and anti-clockwise moment is taken as negative. So third condition, that is C, that is sigma moment is equal to 0. We will take moment about point or support A, moment about point A. To start with, first is my Vd force and I am taking moment at this particular point, right. Now Vd is acting in the upward direction, so my thumb will show upward, right thumb will show upward, and my fingers are moving in anti-clockwise direction. So Vd into what is the distance up to A? 1.5, 1 and 2. So 2, 3, 4.5. So Vd into 4.5, and it is moving in the anti-clockwise direction, so negative. Second is 12 kilonewton. So this is 12 kilonewton. So what is the distance up to point A? 2, 3 and 0.75. So 12 into 3.75. Now again, to know the direction, we will use our right hand thumb rule. Force is in the downward direction, so right thumb is showing in the downward direction and fingers are showing in the clockwise direction. So movement will be clockwise, and clockwise is taken as plus, so positive. Then third is 5 kilonewton. So this is 5 kilonewton and we are taking moment about point A. So what is the perpendicular distance up to point A? 2 meters. So 5 into 2, again it will rotate in clockwise direction, so positive. So 5 into 2 in the clockwise direction, positive. And then Va, the line of action is coinciding with the point or the moment center, so there will be no horizontal distance available, it will be 0. Similarly, our horizontal component is coinciding with A, so that will be also equal to what? 0. So that is equal to 0. So if I want to find out the value of Vd, we can find the value of Vd, that is 4.5 Vd, that is equal to 12 into 3.75 plus 10. So, Vd that is equal to 12 into 3.75 plus 10, 55 divided by 4.5. So, 55 divided by 4.5, and that is equal to 12.22 kilonewtons, right. So, if I substitute my value of Vd in our equation number 1, I can get the value of Va. So, Va that will be equal to 17 minus 12.22, that is equal to 4.77 kilonewtons, right. So, I have found my reactions, that is Va, Ha and Vd. Now, what is left out? Reaction will be only one, right. So, can I find out the value of resultant for this particular force? You can see at this support we have got Va and Ha. Support is 1, so there will be only one resultant force acting for these two forces, right. So, how can we find out the value of resultant force? So, our last step will be to find out the resultant at hinge support. Now, if we see over here, what is the value of Ha? Ha is acting in this particular direction, right, and Va is acting in this particular direction. So, I can extend my line of action of Va. So, if I extend the line of action of Va, Va is acting over here. So, now we have got two forces P and Q, or we can say sigma H and sigma V. So, resultant will definitely pass from here, right. And what is our equation by using our method of resolution or composition? That resultant R, that is equal to under root of sigma H square plus sigma V square. So, what is over here sigma H? Sigma H is nothing but our horizontal component, that is Ha. And what is the value of Ha we have found out? We have found out the value of Ha as 8.66. So, 8.66 square plus sigma V value, what we have calculated sigma Va? Sigma V is nothing but vertical force, and what is our vertical force? Va. So, Va we have calculated as 4.77. So, plus 4.77 square.